So, okay. And then I'm going to turn off my video, not because I'm signing out or anything, but just because I fidget and I don't want to be a distraction. So,
No worries. All right, so I have it here. Can you see my screen?
yes. Oh, no, it's coming up. There it is.
Yeah, there you go.
All right, I'm going to go presentation mode, and then I probably have to flip screens. So give it just a moment. I have to flip screens, right?
Yeah.
Yeah.
Right now we're seeing that
Mhm.
the thing where they show the slides and notes.
There we go. That's better.
Perfect.
Very good. And let me see if I can get set up here because it's a little, what I'm looking for is the chat. I'm gonna move that over. All right, great. So hopefully I will maintain the chat as we talk, so I can see questions. It's a little awkward when you have a couple screens going. So first of all, thank you so much for this opportunity. I am really happy to be here. I actually joined this chapter, I'm going to say at least 2003, and 2004. And then I took a break for a while, had a child, got my doctorate, and so it's been a while, obviously, and it's good to hopefully get more involved is my plan. So I'm talking today on industrial DevOps as part of the introduction. I did release a book in 2023 on this chapter or on this topic after releasing several articles with industry through this technology leadership forum that I participate in. And bringing to the challenges of what does it mean to apply like Agile and DevOps to building cyber physical systems. So that's what we're going to talk about today. And if some of you might have already seen this or portions of this before, there are some variations. So it's not as the same exact presentation, but it is similar. And we can ask some questions about that as we go through this. So we already did the intro, so I am not going to go through that again. I do work for Northrop Grumman. I report through our space systems sector, and I have been part of Northrop Grumman for over 22 years now. And it's a great place to be. So starting with the topic of industrial DevOps, and what does that actually mean? And I think, we're probably familiar of DevOps and, in the software environment, but what we had discovered with this industry team is that we have these challenges in cyber physical systems where we want to take advantage of lean and agile and measuring flow. But in a cyber physical system, I have hardware and software and communications, embedded software, and it's a little bit more complex, but we still want to be able to be responsive to changing needs and reducing lead time. So we're taking the ideas of agile, DevOps, lean manufacturing, systems thinking, and scaling agile and kind of putting them together in its application of these complex systems. Okay, so I'd like to ask you, I think we're a small enough group, what are some examples that come to your mind when we talk about cyber physical systems? You can, I think we're a small enough group, we can have that conversation. Like, what do you think?
What about drones or something like that, maybe?
Yeah, exactly. I'm actually working on another industry project with drones, and it's kind of tackling a similar problem where we're going to take these principles that I'm going to share with you, these success patterns, but also talk about the integration of a modular open systems approach, and put it into the scenario of these drone and emerging capabilities and how they're being leveraged. Yeah, and so that's a great example. Another, you might think about vehicles, or even your phones are kind of more simple examples. But everything's kind of becoming a cyber physical system as we're integrating software and sensors, and with so many of our systems these days. When we first started, and I say we because Robin Yeaman is my co-author in this, she was working for Lockheed at the time. She's now over in Leidos. And we were, talking about in the context of things like the F-35, or, the B-1, or, there's other like large systems, complex systems. And what would it mean what would be the success patterns we would look at and apply to those systems? And it all started then the conversation around, well, what are some of the problems we're trying to solve, right? And it's like, well, we need alignment around our stakeholders, making sure we have this kind of common vision. We have to work with our engineers, our systems engineers, our software developers. How do we get them aligned around a value stream? How do we decompose the system in a way that's easy for them to work a little bit more independently, yet having regular integration? How do we have improved transparency of what's actually working? Historically, we've had large batch sizes, and I think, it's kind of a little bit more common knowledge, and understanding of trying to reduce those batch sizes. And very much focused on how do we improve improve our ways of working to more modern systems engineering approaches, a more modern and responsive acquisition process, and working with our suppliers to engage them more rapidly when we need to surge. And then we got this challenge of long lead time for hardware procurement. That's still an ongoing challenge, of course. We haven't tackled all of these challenges, but we are looking to figure out how to continuously improve and deliver that value in the shortest sustainable lead time. The other thing we have like some unique challenges, especially for safety critical systems, because not only do we have the long lead times and understanding that all the requirements and the dependencies between different components or subsystems. We have an expanding attack surface, right? As we have more and more kind of signaling and communications going on between systems, that creates more risk, more cyber risk. A lot of times we have regulatory and compliance that we have to kind of build in along the way. So it's definitely not an easy problem to solve, but how can we do things better and faster? And so working with industry on all of these challenges, we came up with these 9 principles. And these 9 principles, I kind of refer to them often now as success patterns that you would look at. And some of them, I think after we've been talking about these for a couple of years now, I think we would probably combine some of them. And I'll talk about that as we go through this. Because you're going to see the integration or how closely aligned some of these success patterns are to each other. We've actually done some workshops on that also, like taking into consideration which one of these, have to work together in order to deliver its benefits. And I think that'll become transparent as we go through this. All right, so what are the benefits? So I talked about the challenges. So the flip side of that is like, what are the benefits we're looking for? We want to deliver in the shortest sustainable lead time. We want to improve collaboration, the knowledge sharing. It's not just something software does, because what happens often as you're building a system, if only software is applying these practices, you create these bottlenecks. So how do we actually streamline that process across functions? how do we continuously learn and experiment and get fast feedback to improve the product? How do we, ensure we have engaged employees or engaged workers, and how are we aligning their work, to the vision and the mission that we're trying to achieve? All right, so I don't actually have a poll, so we're going to use the chat. But I'd like to know a little bit about, like, what comes to your mind when you hear the word DevOps? So we call this Industrial DevOps. What do you think the DevOps part of that means? Or what is your familiarity with DevOps? You can either, I guess, talk, because there's not too many of us, or just put something in the chat. Kind of curious of what you're thinking.
I guess I usually think of software development in terms of, DevOps and continuous delivery and that sort of thing.
Yep. Anyone else?
I was going to say CI/CD pipelines. I'm not a developer, but I work at the Space Telescope Science Institute, where there's a lot of development, and that's what I hear a lot. That's what I'd say.
That sounds really cool, by the way.
It's awesome. I've been there for about 2 years, and it's a really cool place.
Yeah, that would be great. Yeah, so we're going to talk about this just a little bit, because I'm not going to get into the details. So I'm watching the chat exactly, and it did start in software, right? So once upon a time, you had like development in one corner, and you had operations in the other corner, and development has the stress, right, of getting stuff out the door, deliver. And you had the poor operations people who had to maintain, sustain, and keep the product running once it was released. So I was actually working in an environment like that before coming to Northrop. So, over 20 years ago, I was working in a tech startup, and I pretty much spent most of my time on the development side. I spent enough time in operations to know that is not my strength. I much more enjoy working with teams where we're building a product. However, my job was to get capability out the door within 3 months of getting a statement of work from my account manager. And he would give me a lousy statement of work. It might have 2 requirements, and I'd be like, "Are you serious?" But as soon as I had that, I had to go work with the customer, get the requirements, and literally deliver something in 3 months. And we mostly did systems like ERP systems, CRM. So if you're familiar, like with Salesforce, it was things like that. So there was already sort of a vanilla base of a product, but it was we also hosted their product. So there was a lot of requirements around disaster recovery, around backups and security, and what is it they actually wanted the product to do to make sure we were putting in the right capabilities. And so my team were like, okay, well, we got 3 months to figure this out and get an initial capability delivered, because that's where we started getting revenue, or at least recurring revenue. And then ops would always push back to make sure every check and balance was looked at, right? Things had to be really sustainable from their perspective. And so there's always this little bit of pressure between us. And so at the time, I was like, let me go downstairs where operations was and learn a little bit more about their job, so I could figure out what it is they're experiencing in operations, because it might help me do my job better in development. And so I learned a lot about the operations side. I spent 4 hours with them every Monday for a couple months, and just, again, sitting with them, watching them work, and then capturing their processes for them, because we're like, well, if you're going to be here, you might as well. What do you think about doing some work for us? But it was all helpful for me to understand their needs. I guess, applying some level of empathy in the job that they were having to do. So DevOps came along in 2009. Was when the idea was brought to industry about bringing these teams together. engaging them more so that it wasn't kind of us and them, but we were actually thinking through a CI/CD pipeline and reducing those gaps. So we built off of that. We're like, okay, we get it for software. We get continuous integration, continuous delivery, or in some places, release on demand. But then we got to thinking, okay, what does this industrial DevOps mean? So we're taking the concept of Dev and Ops, right, and ensuring continuous integration, continuous delivery. However, when we're building a new product specifically, right, we've got this manufacturing piece in there, and that's where the industrial part comes in, because we're really thinking too in terms of the hardware and the manufacturing. And we want to figure out how do we, build a continuous state of flow? What does that actually mean? In really large systems, that obviously becomes more and more complex. And then how are we getting feedback and continuously improving the system? And so it starts looking a little bit different, similar, but there are some considerations you need to take and apply as you're looking at hardware and software type of systems. So let's go through. We have 9 principles to walk through. And the first one is about organizing around the flow of value. And what does that actually mean about organizing around the flow of value? So I assume you all are familiar with value streams, hopefully. Yes, no, anybody?
Yes.
Yes, okay. Thank you. Just making sure y'all are still there. Right, so the value stream, right? It's how we bring in a customer need. Right, they have a need, they have some sort of capability they want. It could be a new product, it could be a capability to an existing product, or maybe they need a new kind of mission thread, depending on your background. But what is that scenario or need or capability? And then the value stream are all the things we need to go through to actually deliver that capability and get it out into the hands of the users. So again, for software, it's more streamlined, but then I've got to think through both my software and my hardware teams in this case. And this is where it's a little more complex, because I'm like, well, I can't once I start, I always tell people, it's like if you're building a ship, right? I can be agile to some degree, but once I've laid like the infrastructure of that ship, and you can't come to me and say, hey, I want it 15 feet longer. I'm like, that would be a lot of money at that point, right? Once you start getting that infrastructure in place, there's more cost to making changes to physical hardware. But there's some things that we can do to drive down that cost. And that's really important, because that's why we're able to apply these success patterns in cyber physical systems. It's because the cost of change is going down, assuming we are leveraging success patterns. So what success patterns are they, right? One is leveraging our virtual environments. And we've done some of this for years, right? Modeling and simulation. Now those modeling and simulation environments are becoming more and more sophisticated. And we are also able to test some software capabilities in that virtual environment as we move more into the physical environment, production. So we want to think about continuous integration in that software context, in the virtual context of hardware. And then it's more what we call continuous, because we're not actually necessarily integrating all the time in a physical context. And we need to think about how we are aligning the people to do that work. So as we're thinking about how we're aligning our teams around the value stream, once upon a time, right, we might think, oh, we've got a systems engineering team, I've got a software team, I've got a hardware team. And we really want it to become more product focused, so that when we think about the value stream, what are the actual systems or subsystems that we need to develop, and how are we going to align the teams around that? So we have this example of this kind of team of agile teams where I might have these attitude control systems. I might have a navigation system. There might be some imagery, our camera team. I also might have a team that's building the infrastructure for these teams at the same time to make sure they have the tools that they need in order to develop and test and do these simulated environments. Of course, I'm going to have cyber security team. They could be a separate team, or in some cases, teams actually just integrated. And that kind of depends on the organization and how they want to approach it. I've actually found that where we could, it's better just to integrate all those requirements within our teams. But in some cases, you might actually have a separate security team that's really looking at that end-to-end picture of ensuring that we're building in the cyber security requirements that we need. Then we get into the multiple horizons of planning. And one of the reasons we focused on this success pattern was because there's this misconception sometimes in Agile we don't plan. I've even seen teams where they think, because they think of Agile as just working in these 2-week iterations, sometimes there's a misconception I don't need to look beyond 2 weeks. And that doesn't actually work when you scale for cyber physical systems. I'm not sure it works actually. I think it works in very few places, except for when you have a well-defined architecture and maybe you already have a product release and you're just pushing out updates, or small and software improvements. But most of the time in cyber physical systems, we need to think about, like, maybe we're building this autonomous vehicle and we need to think about, well, when's the first release of that vehicle going to be? Maybe that's a year out. And if we think, okay, if it's a year out and it's a new vehicle, we need designs, we need to think about, what are the milestones along the way? Or is there an MVP, like a minimal viable product that we're going to test? And then we lay out that roadmap. And I highlight this because it's surprising to me that this step is still sometimes missed. And so if you think about an epic, just think about, like, what is this larger capability that we want? And in this case, it's adding a new camera along with hardware updates to maybe it's an existing autonomous vehicle that's already out in the field, and we're just updating the camera portion of it and updating the software. But just updating the camera and enhancing the safety features around it, right? We might have new sensors. We might want to do, might impact the braking system, right? Because if we're going to improve the safety of the vehicle, and looking at how we want to do improved obstacle detection, right? So we think about it, like, what are all these things, the camera, the braking, the sensors, all that has to come into play. And then we start mapping out that roadmap. And then we might have some opportunities there for milestones where we could actually do some integrated demonstrations. Right, data-driven decisions, there's two perspectives of this to consider. One is the fact that we are basing progress on things we can demonstrate. And based on those demonstrations, and we've done these things for a long time, right? I mean, of course we do demonstrations, that's how we get feedback, but we're trying to think through, what are the more frequent demonstrations that we can do in terms of capabilities, features, and user stories. And then how can we demonstrate those improvements? And again, it might be in a software environment first, and then we go moving into hardware in the loop environments, or various modeling and simulation environments where we can actually measure progress through these demonstrations. So at the story level, at the iteration level, it might be 2 weeks. maybe for an integrated capability, it might be more along the quarterly boundaries. And then on the right, we're like, well, it's not just demonstrations. To make data-driven decisions, we also need, we have all this data now, right? We should be having the opportunity to have it integrated systems, that it's also creating some dashboards, giving us the data that we need to make more timely decisions. And the picture here that we're looking at is, if you notice, we have a physical product, and because this is another opportunity where, let's just say we have our satellite or our vehicle and it's already out in production. I can actually have a digital twin, and digital twin is not just a digital model, but it should have this communication back and forth so that as I make updates in the digital twin, I can actually see how it might react in the real environment before we actually push out new capabilities. But I can also get real-time data, like from all my vehicles that are out in production. And then getting that real-time data, I can do some predictive maintenance and really kind of see how things are operating, and might actually prevent outages or critical situations. I've heard a story. I think probably, have you all heard stories like about Tesla that does this? Has anyone heard? Like, so Tesla has supposedly, I haven't seen it, but I've heard about it, has a digital twin of all their vehicles. So what they do is, with the digital twin of their vehicles, they can actually also aggregate that to see not only how the individual vehicles are performing, but they can also get the aggregate and look for commonalities to see if there's common issues amongst their vehicles. So they know if there's a faulty application within those vehicles. So we want to make data-driven decisions both on the system in terms of what we're able to demonstrate as we're building out capabilities, but also leveraging data in terms of progress and feedback, and making more quantitative decisions as well. So architects for change and speed, I think this is one that you are probably all familiar with, I would think. Learn these lessons early on, I think, in terms of understanding the need for modular architectures. Are you all also, anyone, have you had conversations around MOSA? Is that something that's been part of your conversations in the past?
For me, it has. Yeah, I've been on previous programs, DoD programs that were using MOSA.
Yeah, calling for that modular open system approach.
Mm-hmm.
And right, and the reason like that's being asked for is for that long-term sustainability, right? So that so one, it avoids vendor lock on the acquirer side, but it also enables the ability to change and make updates even a little easier once it's been released. But I also learned personally the importance of a modular architecture where, or I had teams, and every time they were making a change, it was just having this rippling effect across other teams, and we're like having like little mini like fire drills everywhere. And we recognized that we really needed, well, we didn't know what it was causing it for a while. And then we decided, someone had the idea of like, hey, let's look at the architecture. And we're like, we had a tightly coupled architecture so that it was making change really difficult. Then we were like, well, how can we improve the architecture to be more modular? And if you think about it, so we started looking at our system, like our computers. Like you have an operating system on your computer that doesn't change very much, but if it does change or something bad happens, right, everything fails. So we're like, okay, what's like the core operating system for our product? And we want to ensure that only a few people can touch that core operating system, because everything will break if that breaks. And then we're like, okay, so we were doing different like forms of data collection. So we thought, well, how can we organize the architecture or shape the architecture so that if we are making changes in one area, it doesn't impact everybody. And we kind of thought of it like apps on a phone, or like your apps on your computer, right? Can we kind of modularize those things? And then we kind of organized our teams around those systems. And that gave us a better architecture for making change. And then we found that teams could actually act a little bit more autonomously once we made those changes in the architecture. Has anyone else ever experienced something along the lines of the need for modular architectures?
Yeah, I had something similar where we had a homegrown e-commerce system, and we were running through exactly the same thing. It kind of all been written by one person, and everything was coupled. And so anytime we were to make a change, there was this ripple effect, and it was driving management crazy, because they would say, well, we just want what they thought would be a small thing to do. And it seemed like a small thing, but then because of the ripple effect, right? Actually, there's some tools out there that you can use that'll show you coupling and cohesion in your software modules. And so we actually did some of that analysis and showed that, in fact, yeah, we were highly coupled.
Oh, that's cool. Yeah, I wasn't not familiar with that tool. Yeah, that would be great to have something like that. Yep. All right. Okay. So practical implementation is Planet Labs. They're kind of a fun company where they have this mission, right? They're doing this imagery of the earth, and they look for kind of global changes. They look for changes that might be impacting agriculture, wildfires, forestry, sustainability. So that's kind of their mission. And then what they've done, though, is they have employed actually these practices. They have greatly reduced their time to delivery. I don't recall the exact time. I can't remember now if it's 1 month, 2 months, whatever that time is, but they were able to drastically reduce their delivery time by applying concepts as modularity, well-defined interfaces, right? That's another thing that enables the ability to respond quickly to change, having an open architecture, and along with the Agile and DevOps practices. So that's one of the companies that we were able to look at based on our kind of research and investigations of understanding, like, where are there some companies that have actually applied these and are getting results. And I have a couple more that I'll share as we go through this. Of course, I have a feeling iterating and getting fast feedback and improving flow is another area we are probably all familiar with. The thing with cyber physical systems is there's usually two types of scenarios that are going on. One scenario is maybe software only. And while there's always a challenge with that, right, that is not as complex as when you have to update the hardware as well. So we think about these two different type of epics, or two types of situations as we are iterating. So if it's software only, maybe it's about sensor data. We are working in a simulated environment. We just want to improve. Sometimes it's like in our automobiles, right? Maybe it's just like our infotainment center, right? That might be getting some updates. And that's very different if I actually have to go and replace hardware in my vehicle. So we want to think about these two different scenarios. And we were talking about drones before this started. And that's in the kind of activity I have going on with another industry group. And that's one of the things we're looking at, even with our drones. We have, we have these scenarios we're creating where we're only going to make maybe some software changes to the drone. They're already in flight. We need to just add some different software capabilities. But what if I need to actually make more changes to the drone in its configuration of hardware, or if I need more, drones, kind of like if you think of like a satellite constellation, right, where you have a lot of different of these systems actually communicating with you. So you can actually start with some simple scenarios, and then you get into these more complex scenarios that we need to deal with. And we want to think about, as we talked earlier about that roadmap, right? The roadmap needs to take into consideration the software only updates and then the hardware software updates or development efforts as well. And then where do suppliers need to feed in, and at what point are they going to be integrating? And then as we are continuing this, I provided just another example of Orbit Fab. And this is something that Robin actually spent some time with, is really looking at a company such as Orbit Fab. And it's kind of, has anyone ever heard of Orbit Fab, or maybe the capability of where they're working to create gas stations like in space for satellites?
I have not heard about this, and this is amazing.
Yeah, and go
Yeah,
ahead.
actually, this is Kaz. Yeah, actually, I did hear something about this as well. I follow some sort of tech website, and I think they were, they threw something about that out there,
So-
where the idea is you could, park, and it would refuel. Then that way you had, more years of life as a result of, being able to stay on station and all that.
And just for clarity, any kind of fuel? I mean, is it battery or propellant? What is it?
That's a really good question. I don't know that level of detail. I just know that sometimes, like when there's these systems out in space, they're coming to kind of their end of life, and a lot of times it's just the power that they kind of need to be generated, right? And so it's not that there's anything wrong, like say with the satellite, it's just running low on its energy, on its fuel, so they can actually get kind of refueled. But to the level of detail of what that looks like, I'm not really sure. But I know it can extend the life, say, of a satellite, like for maybe a couple years, which is a lot less costly. That's one example. And that's, there's all different types of satellites in space, right? There's the more sophisticated satellites that are more costly, which is different than, the smaller satellites that are more easily replaceable. So I guess there's probably some trade-offs there as well. And then the other thing to highlight, so as there are one examples, also thinking about sometimes as we're going through and iterating, from an engineering perspective, we might not be ready just to jump in development. Maybe we're iterating and getting feedback on trade studies and looking at different data and results and figuring out, what are those next steps. So it's not always software development that we're looking at specifically, right? How are we actually testing and getting feedback in our simulated environments? Or we might actually be building out our environments at the same time. Yep. Oh, thank you. I see that link. And this is the one where we kind of feel like, we probably, if we had to redo it, I think we would just integrate cadence and synchronization in 2 iterations, because it's very closely related. Because what we're saying is we want to apply cadence and synchronization. So with software, we're used to working on these 2-week iterations. But as we move into hardware, we have, in some cases, we have actually found they're able to do 2 weeks as well, because it's all about how they break down the work and how, we always just say, think about like, what is it you actually just want to demonstrate and get feedback on in 2 weeks, right? Because the 2-week cycle is about the learning and figuring out what is working and what's not working. So you're actually like burning down your assumptions, because a lot of times when we're building a system or we're thinking about what capabilities we want and when we want to deliver them, we need that feedback as quickly as possible, because a lot of assumptions went into that plan. And we think, if we build out, in some cases for cyber physical systems, right, you might have a year-long plan of how long it's going to take to build something, but we want to learn as quickly as possible. Is that plan actually going to work the way we laid it out? And we do that through this iterating and feedback loops. And in some cases, I've also had like where software is, applying these iterations, but maybe hardware is just not ready. The hardware teams, right? They're haven't quite figured out, how do I want to break down the work every 2 weeks? And maybe that's too much. And so maybe they're just kind of looking at their quarterly boundaries, which is, fine if that's where they are. And they think, okay, this is what I want to do per quarter. But then I engage them with the software teams to think about and hear from like software and look for those moments or those opportunities to do early integration and feedback loops. And we want to do that to some level on that synchronization, because if we go back to one of the earlier principles, it's about making data-driven decisions, and we want to do that based on observation of something working, not just task completed. Right, so we integrate early and often. Again, the iterations, cadences, synchronization, and integration are all very closely related. Because we understand, at least from what I've seen, we understand Agile at the team level. What does it mean for me to have a backlog of user stories and demonstrate in software every 2 weeks? What we were driving towards, it's not exactly how well are the teams doing, but how well are we doing at a system level? Are you able to demonstrate integrated system capability? And maybe you can't do that fully every 2 weeks. Maybe you can leverage virtual environments to do that demonstration, maybe. But we want to think about not just demonstrations at the team level, but integrated system demonstrations where it takes multiple teams to integrate and demonstrate a capability. And again, this is where the digital twin starts coming into play, because if I have a digital twin, I can actually test and get feedback in my digital twin and show how something might work and get that feedback before we actually release. So what I included in here, this is a paper that we released in 2024 where we mentioned digital twins in our book, but we didn't really define in detail, like what is a digital twin specifically, and how is a digital twin different than a digital model? So with some research, and I forget the guy's name, this is terrible, but the gentleman that introduced the concept of digital twins, some of you might know him if you belong to the Digital Twin Consortium. But we talked with him and as we were trying to figure out how might we explain the differences between a digital model, a simulation, a digital shadow, and a digital twin itself. And I hear sometimes, even just today, actually, where someone was confusing a digital model with a digital twin, because they actually were able to show a digital model of a city, and they were actually able to show how they could change capabilities to that infrastructure. However, it was only a digital model of the city. It wasn't actually, Singapore, which Singapore actually has a digital twin or some level of a digital twin of its city. And what you're actually doing is getting feedback between that physical entity and the digital entity. And that is the primary difference, at least how we define it based on those that we talk to and are in our research, right? It's the two-way communication, kind of going back and forth between the physical object and the digital object. So any thoughts or questions or comments about that? Have you seen something like this before?
this is all pretty new to me. I really like this sort of spectrum from digital prototype all the way to digital twin, because I've heard the term digital twin and a digital model, but not digital shadow or digital simulations. This is all really cool.
Yeah, and if you want, there's the white paper that's out there, and then we also released a white paper shortly thereafter on AI-enabled digital twins. And all of those are, free to the public. You have to put in your email address to download it. But if you just search on Industrial DevOps and digital twins, you'll get to IT Revolution's site. Anyway, I think they're kind of interesting.
Yeah, that's great.
This is what I
Thank
do
you.
in my free time.
Awesome. Thank you.
Yeah. And just some applications like digital twins is, when we first started writing about this, because we wrote, even though the book was published in 2023, of course, we started the work. It took like 15 months. So whatever 15 months, maybe that was, late 2021 when we started. But digital twins was obviously it was a thing and a conversation, but it has really taken, it's just so much more commonplace to hear the talk of digital twins now. And then what is also interesting is like you don't have a digital twin of everything. So like I was reading about ships, right? You don't have a digital twin of every component of the ship, but you might have a digital twin of the ship and its infrastructure because you want to understand how that ship is going to maneuver, say, through canals. And anyway, so I think it's a fascinating topic. And then you also have like digital twins of your factories. So that you can kind of think about if we move things around in our factory, what is the impact going to be? Are things, actually going to work? Is it going to be more productive or not if we were to rearrange the factory floor or make changes? So again, very interesting. Are you getting, data in terms of like smart factories? That's another area. We can also use it, of course, with predictive maintenance like they do with the vehicles. Urban planning, I think, like I said, I think it's Singapore that's creating a digital twin of their city. We have traffic management, and sometimes there's a digital twin component of the traffic management along with some AI integration. So a lot of opportunities here. I think it's an exciting time that we live in as these new capabilities are emerging. Just fascinating. And another practical application of this is of a space digital twin from Slingshot. And they actually have a digital twin of space. And they do it for kind of gaming and mission planning. And it's not a digital model of space. It's actually a digital twin. So we have a lot of stuff up in space. And so it's actually this digital replication of things that are actually in space and they're moving around as they're going through their scenarios. So I think it's a fascinating way to apply this real world kind of environment that we live in so that they can simulate maybe different missions and different ways of executing that mission. Then we have shift left. It's kind of like shift left everything, right? You might have heard of shift left testing, where you start with testing before you would actually go develop. And that kind of always made sense to me anyway, because I would always want to think, well, as we build this capability, how are we actually going to test that it's going to work? What environments are we going to use? What data do I need? And let's figure that out, before everybody runs off and starts developing. But there's also this like shift left with manufacturing. If you're in building, cyber physical type systems, you might be aware of the importance of shift left manufacturing for a couple of reasons. One is because we want to design for manufacturability. We want to make sure they're getting feedback early. We want to avoid those late discoveries in manufacturing because that cost of rework once it hits manufacturing is significant. And then there's actually a shift towards agile manufacturing as well. So if you think of the factory as also a cyber physical system, that means we are building for modularity in our factories as well. And we have the ability to adjust and adapt. And then if you have well-defined interfaces and the system that you're building is modular, there might even be the opportunity to have more ability to change even when you're kind of in production. So Tesla does some of that now, where they can actually make these changes out on the manufacturing floor. They have their change management system in place, so they actually know what changes are going to be made. And then they have a digital twin of each of their vehicles so that they can continuously monitor at least some of the components of the vehicle. Because I assume that their digital twins of their vehicles is kind of like the digital twin of that ship. It's not every single thing that is replicated in the digital twin, but probably the most significant components. Right, so we want to shift left, early testing, get continuous feedback and automation, right? And I think we've learned early on in the automobile industry, between the European models and Toyota, about the importance of building quality in, shift left with security. And all it is, all we're really saying is that we are thinking about these things earlier and getting iterative feedback throughout and not waiting at the end, because if we wait till the end, it's more costly to make those changes. And apply a growth mindset. So I always say it's really important, that we continuously evolve and improve. We need to know that we don't have it all figured out. And even if we did, it's going to change tomorrow anyway. And I think, what we learned from SpaceX with the Starship, right, is like, hey, we got the data we need. It was all about getting the data and improving our product. Joby Aviation is another example of the different practices that we've talked about, and they're actually in progress of making a digital twin as well. And of course, we run into challenges, right? And some of the challenges is not understanding your value stream, not having the psychological safety that we need to be comfortable with getting data and early, and that level of transparency, and of course, a lot of misconceptions. And interestingly enough, the first state of industrial DevOps was released last year, and it was released through manufacturing. So manufacturing is actually becoming more and more software. There's even a LinkedIn post not too long ago that was about software-defined manufacturing. So again, a lot of changes going on in the cyber-physical realm and all the way into manufacturing as everything becomes more kind of software defined. And these are the articles I was talking about. Our latest one was AI and industrial DevOps teams, and we looked at AI kind of to improve efficiencies within teams and how teams are leveraging AI from development to manufacturing. All right. So what questions?
All right. Thank you. Yeah, we have some time for questions. I see some clapping. Well, I'll start with the first question I had was on your slide that talked about sort of impediments. In your experience, has there been any one single biggest impediment that you've seen across multiple teams, and how do you sort of get around it?
So one of the biggest challenges, people always say culture, but culture is behaviors. But I think the biggest challenge is mindset. Assuming we don't have it all figured out, and sometimes with successes and great experience, we think that the way we've done things in the past is what's going to carry us in the future. And if we need to be open to the fact things are changing, and then people are willing to embrace new ideas and to try things, but that makes some people nervous. So it's I think that growth mindset is the one to kind of look at the most.
Yep, that makes
And
sense.
that ties in a little bit into culture, right? A little bit into maybe ego, and maybe rightly so. I mean, some people, if you've been very successful at doing things a certain way, it might make you uncomfortable to change, but telling the landscape is changing so quickly. I think let's figure out how to embrace the change and how to make it work to our advantage.
Thank you. Questions? At GE, we used to call it the golden gut because you'd always have some guy going, I don't need any analysis. I got this baby right here. I'm patting my stomach right there. This baby knows what's going on. Call it the golden gut.
It's funny.
All right. I don't see any other questions coming in. This has
Hopefully
been
everyone's still awake.
all right. Okay.
That was a great presentation. Thank you.
Yes, thank you.
Thank you.
Hopefully
Hey,
there's
I
a-
have one quick question. I just came to mind. I'm also someone who's not that familiar or experienced with digital twin concepts. But it was interesting that in your slide there, you'd said that in order to be a true digital twin, there has to be that feedback from the physical system delivered back to the cyber model or whatever digital model, so that is the case that it's not considered, is that a key characteristic of a digital twin, that there must be that feedback from a physical system to the
Right, because that way the two systems are always kind of reflecting each other. It is truly
Okay.
a digital twin. Otherwise, like if you only have one-way communication, which is my digital model out to the digital twin, that's what we define as a digital shadow, which we didn't make that concept up.
okay.
We actually found it in research, right? Now we are open to these modifications if anybody has found something different, but at the time of our research, that's what we found. And so like Tesla was the true essence of the digital twin because it's got the feedback both ways.
Okay.
Yeah, it's a definitional thing. And that's the way they define the digital twin.
Yeah.
You don't have the
Gotcha.
feedback, it doesn't mean you don't have a twin. You just don't have the official digital twin.
Sure. And I guess that was originally what I was getting at, is sort of from the definition standpoint. Like I said, I'm unfamiliar with the terminology and the actual use of it. And it'd be good to know, like you hear others talking about it, that's includes.
But I wonder, even with Tesla, how far they go, because the idea is it's supposed to be so specific that you actually have, it's not a digital twin unless you have a digital twin for that particular car that you sold to a customer. So every
Right.
customer has their own digital twin because that car, as you know, right, every car has slightly different parameters, age, and etc. And so the idea is the ultimate version of that definition is, if you have a fleet of drones, every drone has its own digital. I don't know if
Yep.
anyone on that
Got
part, but that's the idea.
Well, Suzette, I was going to
Yes.
ask, is there a particular measures of how people are executing, creating the digital twin? Because I hear the definition all the time that there needs to be two-way synchronization between the digital model and the thing that's in real life. But, no one explains to us that process of how they're actually synchronizing with real life. And what I've been finding when I talk to a lot of folks is there's a lot of people who are misusing the term digital twin as a replacement for M&S, hardware in the loop, pick every single flavor of simulation that you can think of. And so I'm trying to get
Yes.
to the thing of has anybody really measured what, and we can pick it as more of a quantitative thing, or even if it is more of just a broad, even a process style, like CMMI, for example, you are demonstrating the processes that enable you to do that, right? And nobody, I feel like in the research space has really quantified, you're a level 5 digital twin and it has this certain level of fidelity and meets the use cases that you intended. And it is regularly updated with the live thing as a whole. I'm just curious about how it's being measured because if there's a lot of, I feel like, fluff in the space right now until proven otherwise.
So I have seen, now that you say that, I have seen some sort of, I'm gonna use this title loosely because it's not the exact title, but a digital twin maturity assessment. I have seen something, and I'm wondering if the digital twin consortium or some sort of group within that might be working on something around that. But you are correct about people misusing, they use the terms interchangeably. And I find myself having to listen really close when people are talking to figure out, do they really have a digital twin? And then I'm thinking, oh, they're talking, like even today, the person was calling it a digital twin. And I'm thinking, you have a digital model, you don't have a digital twin because it's not a real city, right? You're not getting data from a city and updating this digital model. And actually, the paper where we define that, I actually start with a story with when I was talking to a man on a plane and he was going to his factory and he talked about how he bought this new tool and he was making a digital twin of these switches that they build for data centers and or they produce for data centers um, and that's part of the reason we wrote this paper was because there's this gentleman even then I'm thinking it's not a digital twin and you got a digital model, a digital scan, which was a great thing, right? That he had this and then he can compare every digital scan to the design and specifications to ensure quality of what they're actually manufacturing. So it's a great thing. I'm like, that's not a digital twin. So we were trying to help figure out, like, is there a way, something we can do to help clarify some of the language? It's interesting.
Yeah, what I've been finding with some of my kind of like involvement in this space, like like Dr. says that like I'm really finding that when people use the term digital twin, they are thinking that they have the representation at that moment of time. And so what they'll do is they'll model or build something that represents that thing and it will
Yeah.
work for maybe that day. And then the moment that there's something is changed, right? It's no longer a valid digital twin. It's just
Correct.
like a model that's been now disconnected from its source data. And so I'm hoping to understand more, and maybe this is another like interesting research area that I'm curious about is what are those processes to automate how we connect the digital world with real life? I think there's certain industries like manufacturing, for example, where that's a lot more easier because, our CAD model kind of represents the thing we're going to go build anyway. So there's going to be something that ties us to the real world. But like, for example, the space digital twin thing that you represented, I'm like, we don't know every single asteroid that's out in space. So
That
if
is
there's a
true.
new asteroid that we find in some sensor that we have, are we feeding that sensor information into our digital twin? And is that new asteroid, like how are we verifying that that's a real asteroid and not just a random pickup of the sensor? So I think there's certain places where we can better quantify for certain industries what a digital twin is. I have also concerns about like the maintenance of the digital twin because again, it's a representation. So unless you can automate that with real life somehow, someone's going to be spending money to actually have someone's butt in the seat changing a CAD model all the time. And so it's those kinds of conversations around that interest me more. And I'm happy that at least you like have worked through some of the definition pieces because at least if we can get that started, we can now ask these other questions from a research perspective.
Yeah, I think that's a fascinating topic. The place I would start would likely, like I said, be the Digital Twin Consortium, because I don't know, that's where I would pose the question, because it seems like there has to be in that large group, somebody who's probably thinking along the lines that you are, because I think those are, very valid questions. And And my hope is to someday get more involved in the Digital Twin Consortium, because I think there's so much opportunity there. And I believe in COSI IS and last year over in Ireland, in Dublin, they actually had some discussions around the smart cities and some conversations around digital twins. I don't know if they plan to have those similar topics yet for the International Symposium this year in Ottawa, but that would be another good place to just go around and start asking the questions. And people, I'm sure they're going to have people presenting. I would imagine, I would hope, on a similar topic. And but I think you'll find a mass body of people with the digital consortium.
Suzanne, I think
it's a great topic. Anyway, I'm sorry.
No, I have a question. I saw you referred to architecture, but I didn't see a lot of emphasis on the role of an architecture team or architecture model that pulls things together. And one of your earlier slides, I think it was slide 13, and you showed software development, hardware development, and their processes, but there was very little connection other than towards the end. And the architecture often provides that bridge. And I'm curious to know what your thoughts are on the role of an architecture team and an architecture model in the DevOps process.
Yeah, and I've seen it executed in different ways. I think when you're building a really large system, there is often a team that has that big picture. And I've just seen that many times. And they're the ones that, are part of that agile team of teams. And they might even be even higher than that because somebody's got to understand some group of people of how all of these things are going to fit together, right? So often at the big picture level for big systems, I have seen those types of teams. But what happens, when I kind of talk with these teams is making sure, though, that those same teams are actually integrated. They don't have to be integrated into the Scrum team itself, but that agile team of teams, because let's just take the multiple horizons of planning, and I'm going into quarterly planning, we need to be having those architectural discussions as part of understanding what are we building this quarter, what's the state of the architecture, are there any needed changes in architecture or design, and then sometimes there are lower level use cases that might be fulfilled by a specific team. And then one of the things I often recommend is you need to figure out your specific approach and how you're going to handle that. It's like what is going to work in your environment and how you're structured, and then bring it as close to the implementation of the work as possible. But that's a great point. And that is something we're going to soon be releasing a paper on 15288 meets Agile. And we're talking more principle focused. That's going to be through NDIA. But now you're making me want to go back and read that paper to see if we address that that question, because that's a great question.
Okay, thank you.
Anyone else?
Yeah, I was going to say, I have learned the importance of having an intentional architecture and design, because that's one of the misconceptions. One of the agile principles, right, is the architecture emerges. I'm like, not really. Maybe in some cases, but when you're building these cyber physical systems, you have to have an intentional architecture that's running a little bit ahead, right, of development. And, and that varies depending whether that's, 3 months ahead, 6 months ahead, whatever that magic number is. I really varies on the complexity of the system that you're building. And
You're reminding me of all the conversations we used to have back at Northrop, talking about Agile and MBSE coming together and that kind of thing.
We're still having those conversations.
I know.
All right, everybody. This has been great. Thank you very much,
All right.
Shannon. Or thanks.
Thank you, Suzette.
Thank
Oh,
you.
All
yeah.
right.
Great
Thank
presentation.
you. Have a good
Thanks.
night.
Thank
Good
you.
night, everybody.
Suzette, this wasn't a question about the presentation, but I was just curious about your background. It looks like
Oh,
the
it's the James Webb.
mirror, but also
Yes.
the honeycomb, bees. Ah, that's so awesome.
Yeah, I found it somewhere and I was like, I